Okay, here's our lesson on exponential growth. Last year we talked about how the first number you have is always going to be your starting point. So you all know that means I'm going to start here at 2. And this is growth, right? This number right here is my R. And because it's a whole number, it's going to be growth. So last year all we said was it starts at 2 and it's going to grow and get really, really big. We didn't say this word last year, but there's an asymptote right here. It's never, the basic ones aren't ever going to touch the x-axis. Just so that you see an example for tomorrow, decay is going to look like what's down here in red. So you would still start at 2, but this time it's going to decay because my R is a fraction, so it's going to be getting smaller. So this time my graph is going to look like that. Still going to have that asymptote down here on the x-axis. So let's look. You can see the parent function, that's like the most basic function, looks like this. And I've actually changed it from the book because we know that this is R. The book calls it B. So this is my pattern. You all know that. And then our new functions, some things that we want to note. A is still going to be, in my mind, it's still going to be our starting value. It is also going to be where we have, just remember our transformations. We're going to have vertical stretches or compressions. And then R, still the pattern. This H up here is going to be a shift, left or right. And it's, you got to think about it like that's where the quote-unquote parentheses are. So it's opposite of what you think. So we're going to shift opposite. And this is really the most important part. This K out here is your asymptote. So that's why, like, if you kind of follow me, if you look over here, that's why these asymptotes are on the axis, because technically we only have plus 0 out here. All right? Okay, so when we graph, this might look difficult, but it's really not that bad. Remember, your last number is your asymptote, and it's a horizontal asymptote. So that means I've got a horizontal asymptote down here at -6. And then we're just going to pick 2 points, and we pick the easiest ones. Okay, so we want to pick a number. This is kind of how you have to think. We want to pick a number that's going to make this exponent 0, and we want to pick another number that we want to make this exponent 1. So that's going to be our goal. So to make it 0, we would need that exponent to be -2. So if x is -2. So if we work that option out, that's going to give us 4 times 2, -2 plus 2. I'm just writing that out so you see it equals 0, or -6, I'm sorry. So that's 2 to the 0 minus 6. Anything to the 0 power is just the whole number 1. So like this whole part right here is just 1. So that means I've got 4 times 1 minus 6, which is 4 minus 6, and that's -2. I'll write that a different way, -2. So that means at the -2, I'm going to plot the point -2. So -2, -2. All right, we're going to do one more. This time, remember, we want the exponent to be 1. So that would be if I picked x to be -1. That part you just kind of have to think about. All right, so I've got 4 times 2, -1 plus 2, minus 6. 4 times, that's going to be to the 1 power. Anything to the 1 power is just itself, so that's 4 times 2. 8 minus 6 is 2. So that means at -1, we're going to plot the point 2. So at -1, we're going to plot the point +2. And this is supposed to look like growth, so we're just going to connect, and it's going to go up really, really steeply at the end. Okay, this one's going to be really similar. Still going to have my same horizontal asymptote. So this time it's just going to be at -4. And then we want to pick 2 values, one that makes it 0 and one that's going to make it +1. So 0 is just going to be -3. So -3. So I just plug that in. That gives me 3 times 2. That means 3 times 2 to the 0. All right, that's the whole number 1, so 3 times 1 minus 4 is just 3 minus 4, which is -1. So at -3, I'm going to plot the point -1. All right, and then my other value, to make it +1, is going to be -2. All right, so we'll do the same thing. 3 times 2. That gives me 2. So at -2, I'm going to plot the point 2. All right, and then remember we just draw our curve so that it grows really quickly on the right side. Okay, the last thing that you need to know is how to write equations for word problems. So in general, the form is going to be y equals a times, because we're growing, it's 1 plus r to the n power. Okay, and you already know what all of those things mean. Remember, a means the start. R is just your pattern, or in this case, R is going to be a percentage of how much it's growing every time. And N is going to be the number of terms, or how long we're looking at the problem. So we want to identify here what our different parts are. So it says he purchased it for $12,000, so that's our starting value. Our rate is 14%. Make sure you turn that into a decimal, so that is really 0.14. And then we don't know N yet, so that means my equation is going to be y equals 12,000 times 1 plus 0.14 to the n. And we can simplify that by actually adding that together. So this is going to be y equals 12,000 times 1.14 to the n power. All right, what we want to do is figure out when does this, the question is asking how many years, so we're going to be solving for n, does it take until it equals 60,000? And we're going to do that not with our graph like they show us, we're going to do that with the table in our calculator. So I'm going to pause and take a picture of what that looks like for you. Okay, so I've typed that in my calculator, and I'm just looking for where we have it equal to 60,000, and it looks like that's happening somewhere between 12 and 13 here, right? Somewhere in that time frame, we're going to hit 60,000. So it's asking how many years, so that means our answer is going to be between 12 and 13 years. And all I'm doing is all I've done in my calculator is typed that equation into y equals.